Hi, this is Dylan. I'm a backend engineer on the database sharding team, and I'm just going to give a quick follow-up demo on some of the stuff I've been working on using Postgres logical replication. There'll just be links in the description to explain some more context. Getting into it, I will do a quick demo here of what I got working. So previously I had demoed what it would look like to capture a stream of updates from one database and replay them onto a second database. That's using logical replication, logical decoding. The thing I forgot to mention in the last demo was that we also need to filter those updates so that they're only relevant to the projects and groups that we care about that are actually being moved between shards. So what I got working here is I've updated this decoder raw plugin, which was a plugin I found that turns the wall stream into SQL statements that can be replayed. I've updated this so that it only presents the updates that relate to the specific project that we care about. So for now, this is quite naive. It just takes an option when we start up the logical replication slot. It takes an option for the project ID, and then it looks at update statements, and it looks at the project ID for the row being updated and outputs it if that is correct row that matches the project ID we passed in, or it skips the update statements. So quite simply, I have down here the output of PG receive logical create slot, etc. And a key here I passed in the option project ID filter equals 1. So this means to say that consume the replication slot with the option project ID filter equals 1, and therefore don't print out any update statements for rows that do not have a project ID of 1. So I had an example here of a note that was not in project ID 1, that has a project ID 3, and it has an ID of 212. So when I update that note, I can update it and nothing's being printed in the bottom console. When I update this note with ID 1, which happens to also have a project ID 1 in my database, it spits out the results here. So this is the filtering working. It's only working for update statements, not deletes or inserts. And importantly, this is quite naive in that I'm only passing in a single project ID, but really we actually want to filter by a list of project IDs and namespace IDs, and we're operating under the assumption that all rows will have a namespace ID or project ID so that we can filter in this way, but those are all things that will have to come later. There's another proposal about every table in the database that gets sharded having a column called top level namespace ID, which would simplify this so that we didn't need to pass a list of 2 different IDs in and filter by those. But that's what would come next. So now that I've shown that this is working, I'll give a quick demo of what I did to get it to work. So firstly, I'm in the GitLab project here, and I just created a directory called PG Logical Decoding Output Plugin. I copied the project across that I was using that contained the decoder raw plugin in it, copied the make file, license file. These things are all going to need to be sorted out at some point, and probably this might not end up living in the GitLab project. In order to install this, I just cd into that directory and I run. Yeah, so firstly I copied all those files in, and then that was kind of vendoring them in. Now the plugin's ready to be installed. Every time I run that, it just replaces all of these files, the files that Postgres is using. And then you don't need to restart Postgres after recreating those, but you do need to drop the existing slot and recreate it every time you make code changes there. Then after I copied that in and to the project, I've made just a couple of changes in the last commit. So let me just show that. The few changes I made to this project that are interesting is here, this decoder raw data struct is meant to describe the options that were passed in when starting the replication slot. Previously it had an include transaction option, and I've just added a project ID filter option. This is just the code for parsing the option from the options and then setting it onto the data project ID filter into the top level struct. So we get past some data in here. That is in project ID filter. Okay, so that's the struct added there. This line I added to set it to 0 by default. And then I think the 0 by default, and I didn't really design this deliberately, but 0 by default means it's probably just not going to show anything by default because nothing has a project ID of 0. Yeah, this code here is what I added, which is parsing things from the decoder raw startup callback, parsing the options that are passed in and storing them in project ID filter. Then the next part I needed to add, this was just string value of datum. This was because I was trying to extract the project ID from some Postgres objects, and it's possible there's a much simpler way than this, but this was the code I kind of just copied and pasted from all the logic which is used to output the SQL queries and turn them into a string. I just thought, okay, well, rather than trying to figure out exactly how to turn this datum orig val thing into an integer, I would just turn it into a string using the same code that was already there, and that's basically copy and pasted from above. Then where that's called, I then parse it back into an int after I've just created a string from it. And after I've done that, I compare that integer here to the project ID filter, and I reset the string buffer that's being constructed for outputting and return basically after having emptied the string, so that we don't end up writing anything to the replication slot in the decoder raw update. But there's one of these decoder raw functions for an insert and delete as well that would also need this addition, and I had to additionally pass in the project ID filter to that function. That, if I look here, should be the bulk. That's just the definition changing, so I have the extra argument. That's the logic I showed, and that's passing in the extra argument. So that is the bulk of that work. Yeah, the next logical steps is to make it work for the delete function and the insert function, but that should be simple. And then parsing in an array of integers, which probably looks something like the option taking comma separated list of integers, and then turning those into arrays here or some data structure that can be efficiently searched and compared against the integer that is in the result, in the tuple, as it's called in here, the new tuple. Okay, thank you for watching.